Hello dear students, we'll start lessons on probability theory. This is the first lecture, sets, events and elements of combinatorics. In this lecture we'll talk about the set theory and events and experiment and elements of combinatorics. The set theory, event and an experiment, elements of combinatorics. Just now I've mentioned it. This will be our lesson plan. The set theory. A set is a collection of objects. Sets are usually denoted by a letter, and the objects or elements belong to a set, usually listed within curly brackets. For example, denote by the letter S the set of the natural numbers less than or equal to 5, then we can write the following expression here, which is S equals to, in the curly brackets, 1, 2, 3, 4, 5. Or the another example, denote by the letter A, the name of the set will be. Sets are always denoted with capital letters. The set of the first 5 letters of the alphabet, then we can write this expression there. Or we may say the set of students, set of like fruits, apple, banana, strawberry, or set of desks, or set of pens, maybe set of phones, set of computers, set of buildings, everything. Set is a collection of objects, just now we've mentioned it. Note, set is an ordered collection of objects. The order in which the elements of a set are listed does not matter. Two sets, for example A, B, C, D, E, this one and this one, are considered identical. Look, you can understand like in the meaning of equal, identical. We have A here in both cases, and we have B here, and the C, D is here, and the E. So they are identical. All the elements of the first set can be found in the second, so they are identical. Sometimes a set is defined in terms of one or more properties satisfied by its elements. For example, the set S equals to from 1 to 5, like the elements 1, 2, 3, 5, natural numbers, could equally define it as this one. We can read this. S is the set of all natural numbers n such that n is less than or equal to 5, where the colon symbol, double dots, this is colon, means such that, and precedes a list of conditions that the element of this set need to satisfy. For example, if I want to write another set called m equals to the natural numbers 1, 2, 3, 4, etc., like maybe 100, it's hard to write all the numbers, it's hard to list them. So it's better to use this way, m equals to square this curly brackets and belongs to the natural numbers such that n's less than or equal to 100. In this way we can give sets. There are two ways to denote sets. When an element A belongs to a set, capital letter A, we write A belongs to A. We can read this expression like this: A belongs to A, or A is a member of A. A is a member of A. Like, let us use just another letter because A is like the, in this case also the element, and also we are using A as an article, so it's better to write like B is the element of set A. B belongs to S, or B is a member of S, like this. On the contrary, when an element A does not belong to a set A, we write A does not belong to A. B does not belong to S. B is not a member of S. Let the set S be defined as follows: A equals to, in the curly brackets, 2, 4, 6, 8, 10. We can write 4 belongs to A and 7 does not belong to A. If A and B are two sets, and if every element of A belongs to B, then we write A is included in B. A is included in B. Or B includes A. B includes A. When A included in B, but A is not the same as B, there are elements of B that do not belong to A. Then we write A is strictly included in B. A is strictly included in B. Let's consider one example here. Let me say I have a set B which has elements like 1, 2, 3, and 4, and I have a set A which elements 1 and 2. In this case, we can say A included in B because 1, 2 is already in B here. We can find 1 and 2. This means A included in B, or A is strictly included in B. The union of sets. The union of two sets A and B is the set of all elements that belong to at least one of them, and it's denoted by A union B. Define two sets A and B as following. Their union will be all elements from here, A, B, C, D, C, D, F. If we have two elements, double C, just write one of them. Double D here, just write one of them. All elements here, E and F. So this is the union. Union is also can be written in this form if we have the several number of sets, just not two sets. If we have several number of sets, we can use this notation. I starts from 1 to n, A of I. If I have like the A1, A2, A3, and A4, I have 4 sets, I can use this notation like the union. I starts from 1 till 4, A's of I. So it means the same expression, the union. And the here intersection of two sets A and B is the set of all elements that belong to both of them. And it is denoted by A intersection B in this way. Define two sets, the same sets A and B. So intersection means we have to take same elements. We have C's here and we have D's here. This is the intersection. It also can be written in this form, in the similar way. The complement. Suppose that our attention is confined to sets that are all included in a larger set, omega, capital Greek letter, called universal set. Let A be one of these sets. The complement of A is the set of all elements of omega that do not belong to A. It is indicated with A complement. A complement. We read this A complement. A complement. Define the universal set as follows. We say this is a universal set and A and B's are subsets of the universal set. The complement of A and B are defined as following. Complement of A. We have to take elements which are not in A. In A we have B, C, and D. So take all the elements A and here. So this becomes the A complement. In B we have C, D, A, which is C, D, E included in B. So we take A, B, F, G, H. This is the complement. Now about the second part, event and an experiment. We have event and the experiment. An event is any collection of results or outcomes of a procedure. Event. A simple event is an outcome or an event that cannot be further broken down into simpler components. The sample space for a procedure consists of all possible simple events. That is, the sample space consists of all outcomes that cannot be broken down any further. Sample space is denoted with capital Greek letter omega. It's written like this here, sample space. Now we'll consider some examples for the word event, simple event, and the sample space. Example 1. For a single flip of a coin, the sample space omega, flip the coin, flipping the coin. Omega consists of 2 points, head and tail. Here, the experiment is the flipping the coin. Event could be head, sample space, head and tail. If we roll a die is this one here. This is a die. If we roll a die, the sample space will be 1, 2, 3, 4, 5, 6. This would be sample space. In this case, this 5 is event. This is sample space. Event is 5. Experiment is rolling a die. For a single roll of die, the sample space omega consists of 6 points, as just we show in previous page. For a double roll of die, the sample space omega consists of 36 points, because when I roll a die first time, I got 6 possible outcomes. When I roll it the second time, I still got 6 possible outcomes. In total, I will have 36 possible outcomes. Experiment is rolling the die twice. Event, first time 1, second time 5, for example. Sample space, all these numbers. Total 36 events. Now we move to elements of combinatorics. We have done with the first and second lesson plan. Now we are in third plan, which is elements of combinatorics. We use these elements to count some spatial numbers, some spatial ways of an event occurring. Arrangement of n elements, taken k at a time, it is a k-fold arrangement of n elements. It's called any ordered k-fold subset of the n-fold set, m, which is a from nk. It can be calculated using this formula. Consider an example, following example. A group containing 25 students can elect the leader and its assistant by the way group leader and group leader assistant can be assisted. Group leader can be chosen 25 ways because there are 25 students, and if we choose group leader already, 24 students left to choose group leader assistant. If we multiply them, we'll find the total ways of selecting or electing the group leader and its assistant. This is in probability theory. In combinatorics way, we call this twofold arrangement of 25 elements. The next one is permutation. Permutation of n elements is called any arrangement of all n elements of the n-fold set m, which is denoted with Pn, or the n factorial. It's from 1 till n, the multiplication of the numbers. If we have like 4 factorial, it will be 1, 2, 3, and 4. If you have like 3 factorials, it will have 1, 2, 3. 0 factorial is equals to 1, 1 factorial is equals to 1, like this. 8 books can be placed in a bookshelf by P8, 8 factorial ways. If I have 8 books here, like the book 1, book 2, book 3, book 4, book 5, the book number 6, the book number 7, the book number 8. These 8 books can be placed in a bookshelf by 40,320 ways because they form a permutation of 8 elements. If I change their place, I will have another way. If I change there, another, like 7 ways. If I change the first book with another book, I have 7. So if we change another book's order while changing the first book, we'll have some more, so totaling 40,320 ways to put or to place books in a bookshelf. Then 8 books. The next one is combination of n elements taken k at a time. K-fold combination of n elements is called any k-fold subset of the n-fold set n, which is calculated using this formula. Here we have like a and k divided by pk, which is a and k was n minus 1, n minus 2, multiplication sign, n minus k minus 1, divided by k factorial. If we multiply both sides by n minus 1, n minus 2, etc., n minus k minus 1 by the n minus k factorial, n minus k factorial, k factorial, n minus k factorial. Here we will have a number on the numerator. I will have n factorial divided by k factorial, n minus k factorial. We can choose any 4 students of group containing 25 students to do some work by the following way. So I wanted to choose 4 students out of 25. If in one group there are 25 students, I want to choose only 4 of them, I have to use the combination formula. So it will give the answer in some number. There are so many ways to choose 4 out of 25. The exact number we can calculate using this combination. Good luck, guys. See you in the practical part. So be active.